Okay. Hi, Rudy. Can you tell me a little bit what we're going to see today?
Yeah, hi, Michael. So basically today we're going to look at the workflow for how we can print a spherical dome. We get asked for a workflow like this by many of our clients, and basically we can show how simply by playing with a bit of geometry in Aibuild, we can get a non-planar dome built very easily in the software.
Okay, very nice. And what do we see here? What machine we have?
So at the moment we're looking at a seed flexbot system. So it's an NJ60 Comau robot with a seed extruder on top and legacy seed bed in the workspace.
Okay.
We had an update, so I'm having to update my workflow so that everything is computed properly. And given that this is a non-planar workflow, it takes just a few more seconds than a normal slice to compute the results. As you can see here on the toolbar, we're waiting for it to load. Let's just give it a second.
It has to calculate all the coordinates. I can imagine.
Correct.
And what is the extruder model we see here? Is that the E5?
So this is the
S5?
S25 extruder machine, yeah.
Oh, very nice. And the plinth is a 1 meter plinth.
It's I believe it's a 1 by 2 meter plinth. Okay. These are our calculations are done for the slicing, and we are calculating the simulation right now for the toolpaths, and this is all done. Perfect. So I will guide you quickly through the workflow once it's done loading. Going back to the start. So I started off by creating a simple half sphere within Aibuild. We can generate this using our create. And then I wanted to create a slice where I am in control of the rotations of my extruder. So I started by creating a conical shape, and then I did several transformations for that conical shape to build different instances of it. So I've taken the shape, then I scaled it around X and Y to create a second cone like this, and then I projected this cone onto the bed, so to see where we see it right now. After that, I combined all of my meshes together, and then I just flipped my mesh normals to indicate what direction I want my printing to happen at. And if we look at our sphere, we can see now how the cone starts flat, it switches its angle, and then it finishes off at that cone on top. And using these cones as our guides for the non-planar slicing, we managed to generate a slice that looks like this, where essentially our layers are following the curvature of the sphere, but the angle is limited by the angles of the cones that we specified earlier. So basically, if we just look at the rotations here in our part, let's just do this quickly. If we look at the rotations on our part, we will see that the Z, which is this blue line, is following the rotations that I've specified on the cones in order to ensure that once we get to the top, our extruder does not crash into the arm of the robotic system. And essentially, we managed to print this part without any collisions.
Yeah, sorry to interrupt you, Rudy, but you said something important. You have made guides to control the rotations. I know that inside the software, we can automatically create the lines and follow control the extruder to be either straight extrusion or normal to the layer. Why we are creating those guides in this instance?
Correct. So in this particular case, I wanted to have exact angles at which I want my extruder to follow. So basically, by specifying the angle of the cone, I managed to have full control over those specific angles. Now, it is correct. We do have several other computations that we can do. So we have a different, for example, slicing method, which is our segmented method. And in this segmented method, we get our slices with those rotations following the curvature of the surface without me creating those guides. So there are automated solutions. However, in that particular case, I wanted specific angles which make printing this shape for this specific extruder much easier because I understand more or less what its limits are and what I can do with those rotations. So as you can see here, with a single slice.
Yes, so sometimes you want the automation, but other times when you really need to control every I mean, this is relatively a simple geometry, but it has a lot of cantilever. But you still need that extra flexibility, as I understand.
Correct. So there are many ways to skin a cat in Aibuild, and depending on the level of expertise of the user and depending on the restrictions of a certain machine, we can play around with that functionality in order to get the best results that we want. So as you can see here,
And what
knowing that
about quality? And what about quality? What would be, because, there is always that aspect that, you need to make multiple parts. No one asks actually. Everyone asks how many hours this printed, but no one actually asks how many days of prototypes have been there. So, from your experience, what would be the right approach from the get-go, from the start, for an engineer to start to make sure that overall, through the life cycle of his or her project, was able to be more efficient?
Very good question. So we do offer automations within the software, and the automations can be a great starting point for a user. So usually with automations, we take certain decisions on behalf of the user, allowing them to get to a first prototype as quickly as possible. But then once they are past that point, once they're past the point of slicing and generating the model that they want, they may need to do certain modifications depending on the restrictions of their cell, restrictions of their print bed, the size of their extruder, the reach limits of their robot. And then this is where, when they get into the more advanced stages, where they need that control, where they need that flexibility that Aibuild offers. So the beauty with the software is that a beginner can quickly get the automations and produce a result with a decent quality. But if they want to go for perfection, if they want to tackle every aspect of the toolpath, we offer them the tools to do that as well.
Yeah. Okay, thank you. Just one last question, Rudy. Why there is an opening at the bottom? Can we close that?
Yeah, so we can close that. In this instance, just so I can avoid collisions at the top, and just so that we can get a nicer quality towards the top, I just left an opening, knowing the limits of what this extruder can do, and knowing that there is a potential for it to clash with the actual part. So this is decision that I took, knowing the limits of this extruder and knowing how far it could tilt, especially when it gets to that top region, so that it doesn't clash with the part itself.
Yeah, and sometimes we really need to assess and understand the application we are working on, understanding very well what our machine can do, having a flexible software to give us as much flexibility as we can. But if things can happen easier without 3D printing, we need to be logical and realistic on that, because at the end of the day, we need to deliver a product.
100%.
Thank you very much, Rudy. That was great.